Okay, let's get moving. Let's work on section, I think we're 8.1 now, 7.1. Let me grab the notes. Yes, okay, section 7.1. Okay, let's go ahead and let's get moving. Okay, and I am unmuted. All right, so we're going to go on section 7.1, which is simplifying rational equations. Okay, so let's get that up there. Now, there are basically two different kinds of problems. Okay, now before I hit on those two problems, let's work on simplifying fractions. Now, normally when you have a fraction, okay, the teacher will come up to you and say, hey, what two numbers divide into 4 and 6? And she goes, it should pop into your head. And you go, okay, 2 divides into both of these. And then you go, this is equal to 2/3. Okay. Now the problem is that what happens when we start getting really big numbers? So let's say I have something like, I don't know, 98 divided by 140. Okay. And the teacher will go, what pops into your head? And you may look at that and go, nothing pops into my head. And the teacher will go, don't you care? Don't you care? If you cared, it would pop into your head. And I always thought that's a really terrible way of um, trying to teach fractions, because if I don't see it, I don't see it. Now, there's a different way of attacking this problem. That way is to look at prime factors. So what you want to do here is you want to factor, and then you want to factor. Okay. So now this looks like, we'll see, 98 turns into, because it's even, we know that's equal to 2 times 49, and then we can break down 49 because now we recognize it. Normally, when you have a big number, you divide by 2, 3, or 5. So let's look at 140. 10 and 14, 2 and 5, 2 and 7. You go all the way down to the prime factors, and then you get 2 times 7 times 7 divided by 2 times 5 times 2 times 7. And then you can factor, you can then cross out anything that matches top and bottom. 2 divided by 2 is 1. 7 divided by 7 is 1. And then we get 7 divided by 10. And that's our way of simplifying this fraction without having to memorize the multiplication tables of 98. Okay. Now, just keep this in your back pocket. We're going to use it. Okay. So this idea that we can use factoring to simplify a fraction, just keep it in your back pocket. Right? We're gonna get to this. Okay. Now, let me leave that up there in case you want to copy it. If you don't, you don't have to, but it's up to you. Okay, so we're going to keep this idea here. Now, there are two types of problems in this section. I'm going to write down what the two are. They look almost identical except for the words. One of them says find the domain. And then the other one says simplify. Now, notice that both of these are the same question. So the key is you're going to have to read the directions. Okay, you can't just look at this and move forward. You have to say, what is it that we actually want to do with this? Okay, let me make this, bring this a little bit more to the left. I'm going to just rewrite it. Now, earlier, we sort of mentioned this before, that that when you as a professional are given an assignment, right? As a mathematician, engineer, anyone dealing with any kind of mathematics, it could be even as an accountant or someone doing finance. If someone says, I need a formula to compute something, there's two things you need to do. One, you need to give him the formula. You need to give him the formula in a way in which it is fastest to compute. Computing time is money. So if you have two formulas, one takes forever and one doesn't, you always want to give the faster one. You always want to give the one that's easier to understand, right? So even though this may work, we can speed it up. We can make it faster. And in a job interview, like when I would go to Microsoft and go into a job interview, what they would do is they would push you and they would say, here, make it faster, make it faster, make it faster. And there's two ways of making it faster. One, you could code it and make it faster and cut down on little details. But two, you could look at the math and say, mathematically, how can I remove operators? Because if we do this a billion times, removing a few operators makes it faster. Okay. Now, the next question is, when does this work? Okay, when does this work? Your computer does two things when it breaks. Your computer either crashes or it runs forever. The reason why your computer crashes is because it divides by zero. Okay, so if I have something like this, this is equal to undefined. So if you were to run a program and open the console and window, the console is this little black window, and when the app dies, it would give you the error. It would say something like undefined, or usually it's undef, or it'd say something like NEN, not a number, or it would say divide by zero. It'd give you some message that dividing by zero makes the computer die. Okay. So the question for find the domain is, when does this function work? Okay. This is the function you should use when they ask you this question. The question is, when does this function work? Another way of saying that is, well, when is this expression not zero? When does the denominator become zero? Oh, when does the denominator not equal to zero? See, if it equals to zero, the function breaks, it becomes undefined, and then the patient dies if what you programmed was a pacemaker. Okay. So let's answer this question. When does the denominator not equal to zero? Now, most of the time it's not equal to zero. So sometimes rather than saying when does this not equal to zero, it's easier to say when does the denominator equal to zero and say everything opposite that, right? Just like if I ask a girl out. I ask a girl out, I go, will you go out with me? She goes, no. And then you try to like get her to really like you. Go, well, who would you go out with instead of me? And she just starts pointing at people. That guy, 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 that guy. And then at some point, she realizes, you know what? It's just a lot easier to say this. I will date anyone except you. Right? So when something is, so sometimes rather than saying when is something, it's easier to find the opposite and say everything except that. So let's do that in this case. Let's find the opposite. Okay. Let's find when the denominator is equal to zero. And then you go, how do I solve this? Oh, you solve it by what we did yesterday. We X factor. Now, because we're going to be factoring like crazy, I'm not going to show you the X factor anymore. So if I do a factor and you go, I can't factor like you're factoring, just ask me and then I'll write it on the side. Okay. But we're going to be factoring 4 or 5 times the problem now. So I'm not going to have you copy the factor every time. Okay. So the first thing you're going to do is you're going to factor. And then you'll get x is equal to -2, x is equal to -1. And then let me see how the XYZ wants to answer this question. Let me see what format they're using. Oh, okay. And then your answer is all real numbers where x is not equal to -2 or -1. Don't put a paren or a bracket or anything like that around it. Okay. So the part that XYZ wants you to write is this right here. So when does this work? Whenever x is not equal to -2 or -1. When -2 or -1 happens, what you have to do is do error checking. Okay? Error checking meaning that something is terrible is going on and you have to fix that error. Maybe the person fell down, maybe he had arrhythmia, something happened that is out of the ordinary, and that is when you have to do something. Some of the new medical equipment now, they hook up with your Wi-Fi. So if something happens to, and you get something outside of the domain, they'll actually call 911. Like this person is dying, call 911. I have a CPAP machine where they give me air when I sleep, and it records to a server how well I slept, and it also records to my insurance company. So if I don't use it 4 hours a day for at least 20 days, insurance stops paying for it because they go, why would we pay for it if you don't use it? So now what used to happen when you would this situation happen where you get negative 2 or -1, you just say like you send out an error message, right? But now the computers are getting really the medical equipment's getting so smart now that they'll actually call your insurance, they'll actually call the doctor, they'll actually call 911. Okay. Okay. Do we have any questions on this idea of domain? Okay. This question will 100% be on your quiz, midterm, and final. Okay. Has to be. So I know a lot of teachers skip it, but I really press it. If you're an engineer or you are a computer programmer, anytime you divide by 0, you have to do error checking. Otherwise, if the thing breaks during that time, you're on the hook for it. Okay. Now let me show you the other ways I can ask you this question. Let's try this one. Let's do those two problems. So all you're going to do is set the denominator equal to 0 and say all real numbers except that number.
Professor.
Go ahead.
So the numbers on the numerator, we don't do anything with that?
You just ignore it.
Okay.
Okay. So let me just make it easier for you. Ignore this one, set to 0. It usually makes people uncomfortable to ignore the top. Well, we don't care what number is on top. We just want to make sure that the denominator is not 0. Okay. That's your answer there. Okay, do that last one over there. This one over here, you're going to ignore the top. Set the denominator to 0 and get Oh, excuse me. Now, most of the time when you imagine a program, you go, "Oh, his day is just creating new math and new ideas and stuff like that." 99% of programming is really boring. Most of it is error checking. When this happens, what do I do? Covering your butt in case your software breaks. Most of what you do, the most of your day isn't working on the actual formula. Most of your day when you're programming is when something breaks, how do I recover from it? And then documenting what you did so someone else could like fix or add to what you did. Okay. So that part's done. Now, there's a couple trick questions. The reason why they're trick questions is because um, their domain is not restricted. So let me show you what that means. Okay. Find the domain. Now, notice there's no denominator. There's no, unless you have a variable in the denominator, the domain is going to be negative infinity to infinity, meaning that all numbers work. The reason why there is no variable in the denominator. So whether I ask you something like that or I ask you something like this, x squared plus x plus 2, and then I have 5, both of these will have the same answer. And the reason why is there's no variable in the denominator. Right now, the only way we can get undefined is to have a variable in the denominator.
Professor,
Uh-huh.
for the answer with infinity, this one will go in parentheses?
Yeah, usually you write in interval notation. Sometimes if they're asking you for words, sometimes you'll say all real numbers. This and this are the same thing, meaning that any number works. This never breaks. Okay. Now, so you're definitely going to get a find the domain question. Okay. Now the next question is simplify problems. So we get something that looks like let's go 4x to the 4 minus 16x squared over 8x cubed minus 24x squared plus 16x. Let's see. Yeah, that works. So we sort of talked about this before, that if I have a number and, oh, by the way, the word rational in terms of this section, rational means fraction. So when we say a rational number, that's a number that can be written as a fraction. When we say a rational equation, it's basically one equation over another. It just means that we have a fraction. Now, the way we would simplify this, if we didn't see that 2 divided into the top and bottom, is we would factor the top and bottom, and then we would cross out one for one, whatever matches top and bottom. Okay. So the first thing you want to do is factor. Okay. So go factor. And then the second thing you want to do is cross out. Okay. So if you're stuck on how to factor this, pull out the GCF first. Okay. And then factor this. Okay. This one's going to be the x factor, and this one's going to be the a minus b times a plus b. So from yesterday, if we use the a squared minus b squared, we should get x minus 2, x plus 2. Now over here on the bottom, we're going to do x factoring. So we're going to get x minus 2, x minus 1. Okay, now if you're stuck on the factoring, talk to me. It's better for me to show you earlier than later. Okay, so if you don't know how it went from here to here, I need you to speak up. Okay, and I'll just do it. Okay. Now, what you want to do now is you want to treat each one of these like there's 3 separate things. Okay. You want to simplify this. You want to simplify this, and you want to cross out the x minus 2, x minus 2. Okay. So this turns into 1/2. Okay. I have more x's on top. If you ask me how many more x's on top do I have one extra x on top. And then don't distribute it. Leave it like that. Let's try another one. Let's look at simplify. 15x squared minus 75x over 5x squared minus 10x. So try doing this and make sure that you pull out the GCF first. Okay. Let's see. That's a good question. I grabbed it from XYZ and it's a little weird. Let me make sure. Okay. Oh, no, I see why. There's an X here and there's an X here. So when I pull out my GCF, I can pull out 15x and then I'll get x minus 5. Then I'm going to pull out my GCF out of here and I get x squared minus 10x minus 75. Oops. 2x minus 25. Is that 25? No, 15. Okay, so go ahead and x factor that. The top part is done. This part's done. So just x factor that. So you get 15x x minus 5. Okay. Now treat this as three separate problems. So we get 3x. We're going to cross the x minus 5s out, and then we'll get x plus 3. Okay. So let's go back. Okay. So when you simplify, you're going to factor everything, and the number and the x's you're going to simplify just like you learned before. And the only part that's new is factoring the polynomial and then crossing out anything that's exactly the same. Excuse me. Does anyone have questions? I mean, usually have way more questions at this point, but I think people are pretty stressed out about the factory. All right. Now let's work on some of the variations that come with this. So let's look at something that looks like this. Yeah. So the first thing that you want to do is you want to factor this. Okay. Now let me just sort of remind you how to factor it. The way you can factor it is you change places, and then you pull out a -1. I'm sorry. Like that. Okay. So when you have something like this, swap places, and then switch places. Okay. So do the next step over here. Do the a minus ba plus b over here. So for those of you who didn't do section 6.3, we're going to be doing that over and over and over and over and over. So you got to get to it. So let's remind you guys how to factor something that looks like this. Okay, we're going to do this over and over and over. Okay, there's two terms, and we're going to use this a squared minus b squared is equal to a minus b, a plus b. Now the way we find the a is we take that first term and we divide the exponent by 2. And then the b, the way we get, the b, the way we get that is we take the second term and we square root it. Okay. So for the most part, what you're doing is mostly this a squared minus b squared and factoring the trinomials. That's about 80% of your homework. Some of the other homeworks will use grouping, but most of it is just this and x factoring. Okay. So this turns into and then we'll cross out, and you'll have minus 1 times x plus 3 or minus x minus 3. Either of those are okay.
Professor,
Go ahead.
wouldn't you cross out x plus 3 and x plus 3?
Oh, yeah, you are. Did I cross out the wrong ones, didn't I? I missed. Thank you. Okay, so then I would have this, and then I would have that. Okay, thank you.
Professor,
Mhm.
couldn't 9 minus x squared turn, like, can't you just factor that how it is and get 3 minus x and 3 plus x?
You could, and what would happen is that you'd get 3 minus x, 3 plus x over x plus 3. And then what happens is you have to switch the ordering. See how that negative goes with the x, so just put that in front.
So the rule that x stays on the left applies all the time?
You know, it's not actually a rule. Like,
Okay.
technically, it's okay to have that, but in terms of matching this, it's nice to just say, we'll always put the x on the left only because I don't have to, see, the problem is this one, and we're going to do this problem next. Are those the same thing?
No.
Okay. So it's nice to always have x on the left because then when we compare stuff, it's easier to compare. So it's more of a heuristic, meaning that it's a good rule of thumb, but if you didn't do it, no one would take a point away or shouldn't. Okay?
Thank you.
Yeah. So math is weird in that we have things that you have to do, meaning that if this is a polynomial, the highest degree goes first. But because it's combined in this rational thing, you actually, that rule no longer holds. You could have the x squared over here if you wanted to. So we have all these sort of like guidelines, and they're hard to remember all of them. And so if you put an x squared over here, your high school teacher may take a point away because I like it over here. But that's your personal opinion. It's not the official rule of the rule book. So there are teachers that really like professional like math stylists where they actually know and will quote the rule book. I don't even know where it is. But when I talk to like math PhDs, they'll go, well, in this book, it says in this manual that this is okay because this is the rule whenever you write this kind of thing. And then some teachers will just take points off because they go, I personally don't like how it looked, and you should write it like how I look because I'm your, I put a grade on your value, and they'll take points off. Even and so I've seen it all over the place where teachers will take points off. And I'm like, that's not wrong. Okay. Now we're gonna sort of play off this idea here that There's no rule that says that this x squared has to be written after that 9. These are just two different things that you're subtracting. I can switch places and put the 9 afterwards. So there is a question in your homework that looks something like this. So the first thing you want to do is you want to switch places. You want to have that x coming first. Oh, I'm sorry. Let me do it this way. Let me put the minus over here. I apologize. That'll make it a better problem. That's how your homework is, like that. Okay, I'm sorry. Let's do it that way. So when you first look at it, you go like, oh, they're not the same, but actually they're the same. See, you can pull out a -1, and then all the signs will flip. And then all of a sudden now, that and that are the same thing. Remember the good old days where you could just factor one thing and get credit for that problem? It feels like, I don't know, yesterday, right? And now you've got to factor it twice to get the right answer. Okay. Well, let's look at multiplication. So now we're going to look at rational multiplication. Now, the nice thing about rational multiplication is that it works just like regular simplification. So, for example, if I give you a big monster problem that looked like 49 over times 21 times 9 divided by 35. Instead of multiplying everything and then factoring out, it's just easier to factor everything. And you get 7 times 7, 3 times 3, 3 times 7, 7 times 5. And then cross out. Okay. Now we're going to do the same thing over here. I want you to factor everything, and then anything that matches, you cross out. All right, so go ahead and factor, 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 factor. Remember the good old days where you only have to factor twice to get the right answer? Feels like only, I don't know, 5 minutes ago. So get x minus 2, x plus 2, x minus 1, x plus 1. Then we x factor this one. Then this one, we're just pulling out the GCF. Okay, now cross out everything that matches. So we go boom, 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 boom. I have this left, and I have that left. Sorry. Done. So it's not that conceptually this stuff is hard. It's really time consuming. So you really don't want to leave it for Saturday. You're just going to get buried. Okay, go ahead, copy that, and then we'll do division, which is pretty much the same thing. Okay, and just know that if it feels like we're going faster, we're going faster. Usually the first week, I go a little slower. People haven't been in school a long time. People are uncomfortable with the software, um, just the routine of this class, so we go a little slower. But we're in the heart of it now. So we're gonna go. We're gonna be a pretty consistent 3 sections a day, and we're gonna push pretty hard. Okay, but just know that we only have like 2 hard weeks left, and then we're done. So you've got 2 bad weekends coming up, and then after that, we're pretty much done. Okay, so if it feels like we're going really fast, we are going really fast. Okay, then leave this up here. We're going to work on this side over here. So let's work on division. Okay. So let's say we have something that looks like this. Um, let's just say. Now, before we actually uh, do the factoring, what we first have to do is take the reciprocal. The reciprocal means that I take the thing that comes after the division and I flip the numerator and denominator. So once I flip it, this now turns into a multiplication. So what we can do now is factor everything and then cross out. I didn't flip it. Okay, so now it's a multiplication. Now I have, and then we cross out any factors that are exactly the same. So we give people a chance to copy both things. So let me give you this problem in a slightly different way. Okay. Well, I want to show you that it's the same notation, same thing that we've been doing before. Some of the problems will look like this. Let me write it directly. Um, f of x is equal to x squared plus 4x plus 4 divided by g of x is equal to x squared minus 4. And let's go oh, I have it opposite. X squared minus 4 should be on top. There we go. And it'll say find r of x where r of x is equal to f of x divided by g of x. Right. Go ahead and copy that. It's a big mouthful, but it's more pomp and circumstance than it is anything. Okay, so let's take a look at this. All right, now, all this is saying is that Rx is equal to f of x divided by g of x. So there's a few questions at the end where they have this notation, or they'll use this divide, or they'll use this multiply. Don't freak out. Just take that and divide it with this, right? It's just another way of sort of writing the same problem. So do what we said to do over here. First, take the reciprocal. Take the reciprocal, and then factor everything. So we get x squared plus 4x plus 4 over x squared minus 1 times x squared minus x over x squared minus 4. And we'll get x plus 2, x plus 2, x minus 1, x plus 1, x times x minus 1. We're just pulling out the GCF because both of these have an x. And then anything that's similar top and bottom, just cross it out. Factoring here. You're going to cross out there. Cross this out, cross that out. Cross this out, cross that out. And we end up with x plus 2. And then you're done. If you put the x in front, nothing wrong with that. Okay. Now, some of these division problems are hidden in a way that makes them look terrifying. But let me show you what I mean. Sometimes they're written as a complex fraction, which is a fraction over a fraction. Oops. And the first time you look at that, that might be a little bit intimidating. But if you know this, that fractions mean division. This is the same thing as 6 divided by 2. So if I have some fraction over another fraction, all this is a division. So this right here is just a division. 4/9 divided by 6/5. And then you do the same thing we're doing before. We take the reciprocal. And then we'll factor everything. And then we'll cross things out. Okay, so understand that if you see something like this, it's really just a division that's hidden in a way that looks terrifying. So let's do one of those problems. So for those who are copying, I'll leave this bottom part there. Okay. So let's try it again. I'm gonna make this one. Make it easier, guys. We'll keep it the same as we've been doing. Yeah, let's do that. Okay. So the first thing you want to do is change this into a division. You want to say this top fraction divided, that's what you want to write over here. Okay, so let's turn that into a division. So we get x squared minus 4 over and then we'll take the reciprocal. Now factor everything. Okay. So go ahead, factor, and then cross out. Okay. So we have x minus 2, x plus 2, x plus 1, x minus 1, x plus 1, x minus 2, x minus 1. So let's see what we can cross out. X minus 2, x minus 2, x plus 1, x plus 1. And we have x plus 2 over x minus 1, x minus 1. Okay, so it's pretty heavy. Go ahead.
So I had a question. So
Uh-huh.
based on the division you're doing, so basically the x squared minus 4 at the top, you're distributing it by putting x minus 2, x plus 2,
Yeah,
correct?
yeah. So this turns into this.
Okay, so then where is the x squared minus 3x plus 2?
Oh, this one is, this one right here is going to be here. So let me put a thing around it. This right here
Okay.
is from there. Okay.
So what
This
you
right,
did is you just flipped them?
not flip them. I X factored it. So let's make sure that we know what X factoring is, so we're on the same page. Okay.
Thank you.
So this was from last Friday. Okay. So x squared minus 3x plus 2. What we did was we put it in this x. And then we said that what times what is equal to 2. So that's how we got the x minus 2, x minus 1.
Oh, okay.
Get better? Okay.
Yeah. Thank you.
And then this comes from there.
Okay, perfect. Thank you.
Yeah. So on this one, we're dividing the exponent by 2. That's why I get x and x. And over here, we're taking the square root of 4, which is why I get 2 over 2. Same thing with this one, right? Because this one has 3 terms, which is why we're doing this one. And this one has 2 terms, which is why we're just dividing this by 2 and take the square root of that. Okay, that was a pretty heavy haul. It's going to be heavy all day. Let's go take a 10-minute break. We're just about done with this section. I just want to, the homework has a few different ways of writing domains, so I just want to make sure I go over that. So go ahead, copy that, and let's come back in 10 minutes. Okay, let's get back to it. So before we start, did anyone have any problems with what's going on over here? Let me make sure I took a picture of this. I did, okay. So let's get going. Let me give you guys a problem to try. So we should have okay, so do this problem. Okay, now notice this does not say simplify. So you should not be factoring both the top and the bottom. This is a find the domain problem. So what you're supposed to do is ignore the top and set this equal to 0. Okay. And then you'll factor it. Then x is equal to -2, x is equal to -1, and then your answer, the way they have it in the book, is that they're going to give you something that looks like this. And then your job is to write x is not equal to -2 or -1. Okay. Now, what this means is all numbers, and this bar means where. So all numbers where x is not equal to -2 and x is not equal to -1. So they're going to provide you this part, so don't worry about it. Just know that your answer is x is not equal to -2 and x is not equal to -1. Okay. Now, the thing that's a little bit confusing is that they'll ask the same question, but in a slightly different way. So they'll ask something like, determine the value where x squared minus 4 is undefined. Okay, let me do that. Now, this is the same problem. Okay, this over here, you're going to do all of this. Just in your answer, you're going to go x is equal to -2 and x is equal to -1. The reason why is that we're saying that this is asking when is it not undefined? Well, that's where it's undefined, so it's not undefined everywhere except these 2 points. This is asking it where is it undefined? at those 2 points. So they're the same problem. You're supposed to do the same thing. It's just that when they say find the domain, I'm finding when is this not true? And then when they say where is undefined, you're finding when this is true. Does anyone have questions on that? It's a little bit confusing.
Professor?
Yeah, go ahead.
A quick question I have is on the left, when you have the X and then the line where all numbers where, is that how we would write out an answer if we had a paper test?
I would write this out, all numbers where X is not equal to -2 or X is not equal to -1. It depends on your teacher and your book. Some people will write it in interval notation, where they'll write it like this. Like most books have you write it in interval notation. Where you skip over -2 or -1. So you can use words, all real numbers where this is true, or you can use the set notation, or you can use interval, and you go, which is the right one? To tell you the truth, I think the words are the best ones. Like if I was writing a computer program, I would just say all real numbers except these, right?
Okay.
Because at the end of the day, I think this is the most confusing, even though this is what shows up in the book most often. I think this one or this one are the most easy only because I want to be able to just see it. I don't want to have to like see this big glob of stuff that I have to
Right.
figure out, right? Because at the end of the day, as a professional, you just want to make sure that it's really clear these two numbers kill someone and every other number doesn't.
So when we're doing homework, it's best to read the wording because it might ask you for what is undefined or what is not.
Yeah, so I think in the beginning they start with questions that look like this. And then at the end, I think there's 2 questions that say like find the domain.
Okay.
I like this one because in the future classes, this is what they're going to ask you. They're just going to ask you find the domain, knowing that you should know that this is true.
Okay.
In terms of algebra books, half they're split. Half of them write it like this, half of them write like this. But as you go on through your career, this is how they're going to focus on it. So this is where I tend to focus on it.
Professor,
Go ahead.
why do we ignore the top part?
Okay, so you're asking the really important question. The thing that makes this undefined is if the bottom is 0. If we have any number here, it doesn't matter what number, that's undefined. So we don't care. All we're asking for is when does this denominator become 0? On top, it could be anything, right? Because when the denominator becomes 0, this whole thing turns into undefined and your pacemaker stops. Or your brakes fail on your car. So we don't care what the top number is, right? It can be anything. It could be 5, it could be 51, it could be 512. All of those numbers are undefined. The thing that makes it undefined is the 0 in the denominator. Is that better?
Yes, thank you.
Okay.
So the undefined number. So if you plotting that on the graph,
you can't plot it.
You can't plot. Okay.
Right. So there's a difference between 0 and undefined. Okay. So undefined means not possible, meaning that when I'm running my program and I plug in -2 into here, the bottom turns into 0, and that tells that the pacemaker that it's impossible to do the next command. If it's impossible to do the next command, the pacemaker just stops. So it's actually not a number. It means it's undefined. So if you're to say, how much money would it take for Angela Jolie to go out with me? It's not 0. She won't go out for me for free. It's probably undefined, meaning that it doesn't matter how much money it is. She's not going out with me. It's just not a possible. There's no possibility. So undefined means there's no number that will make this happen.
Thank you.
Okay. So You know, a lot of people, they like all the electronics in their car. I hate it. Every time I see, like, wait, my window's now controlled by a button, my brakes are now controlled by a button, everything is controlled by a button. Like, in my mind, I'm thinking about, all right, so that's how many more programs are in here, and how many more times where they possibly could have missed this? And if that thing fails, did they really test it? I mean, you know, if they sell 1 million cars and it only kills 300 people, it makes sense to make that car and kill 300 people. So every time they put electronics in my stove, in my car, I hate it. I don't trust programs. Okay, so let's go to section 7.2. I'm going to turn into the Unabomber at some point, I think. Okay. Um, So section 7.2, adding rational equations. Okay. Now it's important to know that adding and multiplying with fractions are different. When we are adding fractions, what we need is a common denominator. And the typical teacher thing to do is to go, what is the smallest number that 3 and 2 divide into? And then someone goes, 6. And I'll go, you're right. You must really care because it popped into your head, and only people who care have it pop into their head. And I'd pat you on the head and say, good job. And once we say 6, our job is to make two fractions that have the same amount as what they had before, 1/3 and 1/2, but have the same denominator. If I simplify this, I get a third. If I simplify this, I get a half. In order to make this 6, I multiply it by 1. See, 2 divided by 2 is equal to 1. So if I multiply something by 1, it doesn't change how much is there. It changes what it looks like. Now, once I do this, I have one copy of the denominator, and I simplify the top. Right? One copy of the denominator, and I simplify the top. If that's a negative, the negative goes up here. So now I get 5/6, and I'm happy. Okay. Now, that's always the first question that you get in class. And then you keep going, and then the teacher goes, okay, let's try this. Let's make this 5. And then they'll go, okay, find the common denominator, what number pops in your head? And then all of a sudden you look at that and you go, oh crap, nothing pops into my head. I guess I don't get the pass, right? Okay. Now, for me, I think this is a terrible way of teaching, right? What I would like you to do is to have some strategy where I don't have to worry about things popping in my head. The first thing I would tell you to do is factor the denominator. We're only factoring the denominator. Okay? We're not factoring the numerator at all. Okay? So before, when we did multiply and divide, we factored everything, crossed everything out. This is going to be different because I need to get a common denominator. So the first thing I'm going to do is I'm going to factor the denominator. And then I'm going to say, what do these things have in common? They have a 2 and a 2 in common. That's what they have in common. Over here, I'm missing a 3, and over here, I'm missing a 7. See, I want to get a common denominator. I want the denominators to look exactly the same. So this side needs to get a 7, and this side needs to get a 3. Okay, so let's write that. Let's add missing factors. Okay, so over here, I'm missing a 3, and over here, I'm missing a 7. Right? Now, just like over here, I have to add it on the top and on the bottom, because 3 divided by 3 is 1, 7 divided by 7 is 1. We're changing what this looks like, not how much is there. Okay, so now this turns into 3 over 42 minus 35 over 42. So we're going to simplify the top, and then we're going to we're going to have only one copy of the denominator. So I'll get minus 32 over 42. Let me give people a chance to sort of catch up and copy. And then we'll have to simplify that at the end. Okay. Now, when we get down here, most of the time you don't have to simplify, but once in a while you do have to simplify. So the way we simplified this before was we factored everything. 2, 4, 8, 16, 32. So you factor everything, and you get minus 16 over 21. Now we're going to do this with polynomials, but it's not as bad as you think. Okay, so we're going to leave that up there as a guide of what to do. Okay, so I'm going to erase the left side. Okay. Now remember, this is different from multiplying, dividing, and simplifying. For those, you factor everything and cross out. Whenever you add or subtract, you need to have a common denominator. So let's say I have something like this. Okay. So the first thing you want to do is factor only the denominator. Just factor that, only that. Okay. So we're going to have 5. And then we're going to x factor this one. Minus 1. Okay. Now look at what they have in common. They have these negative 2's in common. Okay. So what you want to do is add the missing factors. What we're missing over here is x minus 1, x minus 1, and what we're missing over here is x plus 2, x plus 2. Let me let people copy and breathe. So I have 5. Now what we're missing over here is an x minus 1. What we're missing over here is x minus 2, x minus 2.
Professor?
Go ahead.
So you get whatever you need and you put it on the other side?
Exactly.
Oh, okay.
Exactly. Okay. Now, what we're going to do now is we're going to
Professor,
go ahead.
didn't you put x plus 2 on the right side?
Oh, yeah, I should. Thank you. I missed it. Okay. Now, what we want to do now is we want to simplify the top, and we want to have only one copy of the bottom. Okay. So on the bottom, I have one copy. I have x minus 2, x plus 2, x minus 1, just one copy. And then on top, I'm going to distribute. I have 5x minus 1 plus 2x plus 4. And then all you're going to do is combine like terms. Seven x plus 3 over.
Professor?
Go ahead.
If you distributed 5 to x minus 1, wouldn't it be 5x minus 5?
Yes.
Right,
I hope I'm not having a stroke or something. All right. Minus 1. Better. All right. Thank you. Okay. So the whole idea here is factor the bottom, figure out what they have in common, because it's this other thing that's going to go on the other side. It's what they don't have in common. Because we want these two bottoms to be matching. Once they match, we just have one copy of the bottom, and we just simplify the top straight across. Okay. Let's try one more of these. Okay. So this one will be 2. Let's go x squared minus 9 minus 5 x plus 3. And actually, let's make this x plus 2. Okay. So go ahead and work your way down. The only thing you have to factor is this one, because this one is already factored. Now, find what they have in common. And by the way, I texted everyone a video you should watch for tomorrow. Okay? It'll make tomorrow a lot easier. Okay. What these have in common is Let me just read. Is this and this. So we should have x plus 2 minus 3, x plus 3 minus 5, x plus 3. So I'm missing an x minus 3 on this side. Excuse me. I really apologize. Sorry about that. Okay. Now, there's two things I want you to get out of this. You don't always have to manipulate every term. Sometimes this is complete. So you may just end up manipulating just one of these terms. The other thing I want you to sort of be aware of is that this -5 belongs to that 5. So when you distribute it on top, make sure you're distributing the -5. Okay? So go ahead and finish up this puppy. So you have x plus 2 minus 5x plus 15. And you have minus 4x plus 17 divided by. Now, most of the time, this and this will not cancel, but once in a while, you can factor this and cancel that on the bottom. But it's pretty rare. Okay, now there are two tricks. There are two trick questions in this section. Okay, now one thing I want you to be aware about is that negative connects with that 5, and usually people are pretty good at remembering that. Okay, now let's look at the one where I usually get people. So this is one of the early questions on your homework, and it looks something like this. Okay, that problem. Okay, so go ahead, let me give everyone a chance to copy and read and think about what they would do. Okay. Now, people look at this problem and go, "Oh, Dr. Kawhi must be having a nice day. He gave us a nice, easy problem." Okay. Now, this is very subtle. Okay. Even though it's not there are parentheses around all of these. Okay. So when we do this negative, what's really happening is that I have a -1 here, and I'm going to distribute it to both of these. Now, most people will get the -5x, but if you get this wrong, it'll be because you missed that negative was supposed to distribute to the 7 also. So this is just an issue when there's more than one term here. So be careful, right? This is a subtle trick. Okay. Now, let me show you how this is sort of played with in another trick on the test, in your homework. So if I have something like this, we'll make this. I'll make this. Actually, you know what? Let me give you the actual problem in your book. Let me. It's a better question than I'm giving you. Let me give you exactly how it's given in the book. So 15 plus 3x plus 3, 1 minus 4x. All right. So this is really subtle. Okay. These two almost look the same. Let's flip these two and see if they're how close they are. So remember that this operator goes with the term on the right. Now I can make these two things identical by pulling out a -1. Okay. So now these look almost identical. So what I can do now is pull out a, well, let's do this. Okay, let me take a picture of what I have on the side over here so I can create some room. Now, there are a couple ways to attack this problem. I could add a -1 over -1 on this side, But I think the book, the way the problem is set up in the book, I want to show you a way that's a little bit computationally easier. Okay, but it requires you to think of a fraction in a different way. Okay. Now, usually at the start of the class, I'll ask this question. And usually what happens is I'll ask the class, is B, C, or D equal to A? And I'll have people raise their hands. And some people will say B, some people will say C. Most people say D. And then some people say both B and C. Okay, and let's figure out how to answer this question. So in this case, that negative is not connected to the 6, so that's equal to -3. Now, a negative divided by a positive number is equal to a negative number, and a positive number divided by a negative number is equal to a negative number. But a negative number divided by a negative number is going to be a positive number. So this is the only one that's not equal to the other two. So if I have something that looks like this, I can put that negative in the middle. Okay. So what I can do is I can move this negative and move it to the middle. So a plus times a minus turns into a minus. Now, the nice thing about this is these two denominators now match. Okay, so if this was a minus times a minus would turn into a plus. Because that's a plus times a minus turns into a minus. So normally what happens is you could have, if you wanted to, multiply that by -1, multiply that by -1, but the math gets a little bit, it's a little bit harder. It's easier if you just take this and then put it up here, and then now these two match. Okay, so go ahead and finish this up. Go and distribute the negative to both of those. All right, see if you can finish it. It has been. Then you have 15x minus 3x minus 3. And then I have 12x minus 3 divided by 4x minus 1. Okay. Now, we got to be careful. Sometimes we can simplify. And this one we can simplify. So if you're not sure, you may need to factor just to make sure that you can see if you can simplify or not. So let's simplify. What you're going to do is you're going to factor this, and you're going to factor that, and you'll get 3 for the GCF, and then these two will cross out. Okay, then we're done. Okay, let's take a 10-minute break. We'll do one more problem that is like this, that's on your homework, and then we'll move on to the next section, okay? We may not finish the next section, but we'll get quite a bit of it done. Okay, so let's take a break till 10:30. Okay. Does anyone have questions on what we did? There's been like strangely few questions, so I know that we probably have a lot of students who are just absolutely lost. Usually, if you're kind of lost, people ask questions, but if you're completely lost, you don't. Take a picture of this. Okay. So, if some of you are just want to have time with this and then sit with it, and then ask me questions tomorrow. Just take a picture of your question, then after class, we'll just sit down and help you with the ones you can't do. Okay, but I know that there are a lot of lost people because none of this stuff is easy and no one's been asking questions. So it just means that the entire class is equally lost but equally shy. Okay. Let's go the last question on this section and then we'll start with, we're going to skip 7.3. We're going to go to 7.4. We won't get all of it, but we will get most of it done. Okay. And get started on this chapter 7 stuff as early as you can because all of this stuff is time consuming. Now, I know I gave a few people an extension on quiz 2. Just know that at a certain point, we run out of time, right? So you get an extension for quiz 2, you make for the midterm. By the time you get to quiz 3, you're so far behind, you can't catch up. So for those of you who got an extension, I got to get you hustling because there's a lot of material going to come. Okay, so let's do this last problem. Okay. So this is very similar to what we did before.
Professor,
Go ahead.
what's the name for section 7.4?
We're not there yet, but it'll be solving rational equations.
Oh,
So it'll look like this, and then I'll say equals 0. And then your answer will be 9, or something like that. You know, let me make these x's so it's easier for you to see. Sorry. X, 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 2x minus 28, and then 49 minus x squared. Okay, so this one is going to work just like the last one did, right? Do you see how this looks like that? So go ahead and flip these, pull out a -1, and then cancel it out with that negative. So if you can follow the directions, give it a shot, right? So this is just like what we did before. Swap these two, pull out the -1, and then multiply it with that negative. See if you can do that. Okay. Now, let me try taking the first steps with you. Now let's flip these. Now remember, that negative goes with the x squared. So now these two almost look the same. So let's pull out a -1. Okay. So now multiply this with this. A negative times a negative is positive. So what we're looking at is we're just multiplying these two. Sorry. A negative times a negative should be a positive. Okay, now finish it up, right? Simplify the top, and then you may need to factor it because you may need to simplify. And then let me, just for clarity, let me put this plus in between. So what we should have is we should x squared plus x plus 2x minus 28 over x squared minus 49. So then that's x squared plus 3x minus 28 over x squared minus 49. Now, the rule is that's an okay answer if it doesn't simplify. So if nothing crossed out and you just left your answer like that, technically that answer is correct. In this case, however, if you factor these, things do cross out. So you only have to factor it if things cross out. If things don't cross out, you can just leave it like that, and that's fine. Okay, so we're going to go to section 7.4. So go ahead and give everyone a minute to copy. Section 7.4, solving rational equations. Now, what I want to do is I want to go back to a problem that we solved before, but I want to solve it in a different way, which will be how we solve these rational equations. Now, let's say I have something like this. Now, what I did before is we would multiply everything by the lowest common denominator, right? So before what we would do is we would multiply everything by 6. Now, what I'm going to do is something different. I'm going to solve this by finding a common denominator. Right. So rather than multiplying everything by 666, what I'm going to do is something a little bit different. I'm going to find a common denominator. Right? So the common denominator for all three of these would be 6. And then I'm just going to factor that. So we could see that using the same technique we did before, where we factor the denominator, you say what's missing. This one's missing a 2 and this one's missing a 3 because this one has a 2 and a 3. Now we have everything having a common denominator. Okay. Now at this point, I'm going to now multiply everything by the common denominator. So I'm going to multiply both sides by 6. And then, go ahead.
Where did you get the 1/6 from?
Oh,
It's 3/6.
Thank you. Thank you very much for catching that. So now what will happen is that we'll get the 6 times 2x over 6 plus 6 times, 3 over 6 is equal to 6 times 5 over 6. And then what we'll do is we'll divide the denominator with the lowest common denominator, and we'll end up with 2x plus 3 is equal to 5. So go ahead and copy that, and then let's have a conversation on why I made the change in place. Let me factor the denominator. Okay, so go ahead and copy that, and I want to explain why I made that change. Okay. Now, the reason why we're doing it this way is that I want these problems to use what we learned from the previous problem. In the previous problem, what we did is we got a common denominator. We factored the denominator, and whatever was missing, that's what we added. Okay. Now, if we look at this line and we look at this line, do you see when they have a common denominator, when we have a common denominator, we can go directly from this line to this line. So when we have a common denominator, I can just cross it out. So the reason why I want to do this, it just saves a lot of writing. I can try to find a common denominator when I have an equation, and then if they're all the same, I can cross it out, and I can go directly from here to here. That's the jump I'm trying to make. Okay. So let's try this problem. Okay. Let's try to solve this problem. Okay. So let me have things with x's in it that look particularly scary. Let's do something like, oh, that looks good. Let's do 1 over x minus 1 is equal to 2x plus 1. That's a happy problem. So let's find the common denominator. What's missing on this side is x minus 1, and what's missing on this side is x plus 1. Okay. Okay. Now, do you see how we have this situation where everything matches? When everything matches, you can just cross this out, and now you have this problem. And we know how to solve that problem. We just distribute and then solve for x. So go ahead and do that. So people tend to like this problem better than the last problem we did because I get to just cross things out. And now this problem looks very familiar. Now, subtract x, add 2, and then we get x is equal to 3. Now, I'm sorry to say that there's always a little small print from the lawyers that come when we do this problem. There's always a little small print. This might be correct. All right. And then the question is, what the hell does that mean? It means that if there's an answer, this is the answer. But then again, there may be no answer. Okay. Now we're going to go into that in more detail, but I want to do one more problem just like this so that we can contrast them. Okay. So just know that there is a little small print that the answer is 3, maybe. It can't be any other answer, but there is an answer, it's 3. Okay. So let's do another problem that looks just like this, and then that way we can contrast when the problem works and when the problem doesn't. Okay. So let's try this one. Wait, not that one? No, wait, not that one. Let's do, I take that back. Oh, here we go. This is better. X minus 4. And then equal to 8 x squared minus 16. That's a better problem. Okay. So let's do what we're doing before. Let's find a common denominator. So first factor this. So we get 1 x minus 4 equal 8 x minus 4 x plus 4. Now, what they have in common is this x minus 4. So this thing needs an x plus 4. Right? Now, this is just like the last section. Now, the difference between this problem and the previous section is this one has an equal. That's why we can cross out. The other section just looked like that. There was no equal sign. That's why you couldn't cross out the denominator. Okay. So now that everything has a common denominator, oh, I'm sorry. Yeah, that's right. I'm going to cross this out.
Professor,
Go ahead.
why are you adding like x plus 4 on the left side, but not like there's nothing else on the right side?
Okay, so I need this bottom to look like that bottom. Like I need this to look like that. So if I put the x plus 4 here, this bottom and that bottom is the same. On this side, there's nothing here that's missing over here. That's why I didn't have to add anything.
Oh, okay.
Okay, so our goal is for that bottom and that bottom to be the same. Okay, so now we have this problem right here. This might be correct. Okay. So go ahead, copy that, and then let me do the hook that's on this section. Okay, now let's see what this actually means. Now I'm going to teach you an easier way to determine whether this is a correct answer or not. But let me just show you what it means when it's not a correct answer. So let's try and double check this. So we're going to plug in x equals 3 into the original equation. Okay. So I'm going to get 1 over 3 minus 1 is equal to 2 over 3 plus 1. And that turns into, is a half equal to 2/4? And the answer is yes. If I simplify that, I get a half is equal to half. This is the correct answer. So now it's not just might be correct, we know it's correct. Okay. Let's do the same thing here. Let's double check. So we're plugging x equals 4 into this original thing. 1 over 4 minus 4 is equal to 8 over 4 squared minus 16. and I get 1 over 0 is equal to 8 over 0. So this is undefined. And even though it's undefined is equal to undefined, once you get a 0 in the denominator, you just know that the answer is garbage. So my answer is no solution, undefined. There is no answer. So go ahead, copy that. Go ahead.
So unlike most problems we did in the first 2 weeks, there is a chance that they might be wrong. Like we have to double check these.
Yes. So the way you think of these problems is if there's an answer, then this is what it would be. Right? So on the right side, if there's an answer, it would be 3. Now you could double check it, but for some of these, they're really hard to double check because your answer will be a fraction. So then you got a fraction inside of a fraction, and you're adding and subtracting them, and it just sucks. So there's an easier way. A little cheat I'm going to show you. Most books will just tell you, "Oh, plug it in again and see if it worked or not." Okay. Now let's look at the easier way to figure out whether this worked or not. The reason why this did not work is because the denominator became 0. So if you plug in this answer into the lowest common denominator, you get 0 anywhere, you know that it's a bad answer. See, if I plug in 4 into here, 4 minus 4 is 0, boom, bad answer. But if I plug in 3 into here, 3 minus 1, that's good. 3 plus 1, that's good. I don't have to worry. 3 is a good answer. So the easiest way to do this is plug this into the lowest common denominator and see if you get 0. So the lowest common denominator here is 4 minus 4, 4 plus 4. 0 times 8 is equal to 0. Bad answer. Plug in x is equal to 3 into lowest common denominator, and then you'll get 3 minus 1, 3 plus 1 is equal to 2 times 4. This is not equal to 0. Good answer.
Professor,
Go ahead.
What if we double check and then, but it's not 0, but we get like the two side different value, which make it incorrect? How do
That
we
means that this number is wrong. Somewhere you messed up. The only way you get a bad answer is if the denominator is 0. So if you
That's
double
it.
check it and the left side and the right side are not equal, then you messed up something over here.
Thank you.
Uh-huh. Okay, so let me give everyone a chance to copy that.
Professor.
Go ahead.
So in XYZ, if we had the equation on the left, the answer would be DNE.
Let me see. It'd probably be DNE. It does not exist. Okay, now let's see. So let me show you what I have to help you. Let's see. Let me share screen. Okay. So on this left side are videos by section. So if you want, if you're really lost, here's how to find domain. Here's how to simplify. Here's how to multiply, divide. Here's how to add and subtract. 7.3 we skipped, but 7.4, the current lecture, I completely did myself. So if you're lost on 7.4, that's this lecture done from scratch. These other ones are just basically people I found on the web that explained it the same way I did. And then in terms of 8.1, I emailed you 8.1 because 8.1 is now another one of those core things where all of chapter 8, we're going to do everything 8.1 over and over and over and over. And you can kind of see it over here. If you can't factor, you can't do anything this section. Same thing is going to happen in chapter 8. If you can't do 8.1, you won't be able to do anything for the entire section. So it'll help you to just spend the 15 minutes to watch that video before you watch the lecture. It makes a big difference. You'll ask better questions. Okay, now the other thing I have is this rational worksheet over here. Okay, so it has solutions and it has questions. And these are typically how I ask the questions. So, and they're all mixed up. So they'll have find the domain, they'll have division, they'll have subtraction, and all the different sort of variations that I did on the board, they're all here. So once you finish your homework, if you need something to look at to make sure that you can do things out of order, I would do this worksheet. All the solutions are there exactly how I did it. Now, how I usually teach this is that when you find the lowest common denominator, I usually tell people find the domain, meaning that all real numbers except for 0 and 3, that's what the domain would be for when we would look at the lowest common denominator. So then you see here The answer can't be 0 or 3. Either technique works. Because we don't have a lot of time, I'm just telling you, hey, take your answers, plug it into your lowest common denominator, and if you get a 0, cross it out. Okay? So if you want to go through these problems all mixed up like the test will be, then they're all right here. Okay? And that worksheet is just right up here, rational worksheet. Okay? And the factoring worksheet that we did, so we have two worksheets here for factoring. One of these only is factoring, no solving at all. So I'm asking you to group. I'm asking you to do the a squared minus b squared. I'm asking you to do the a cubed minus b cubed. I'm asking you to do the x factor, and it's all mixed up. So this is section 6.1, 6.2, 6.3. Now, if you want to see what your tests look like, I have a factoring problems from old exams. So half of these problems are factoring. Oops, sorry. Usually the left side is factoring, and then the right side is solving. You don't have to do this entire thing, but just know that I'm going to ask you to solve with a GCF that has an X, solve with a GCF that doesn't have an X, and then I'm going to ask you something like that, where you have to FOIL it and then subtract. So if you want a sense of what I'm going to pick, basically each one of these is a separate midterm that I've given. So once you look at this, you'll go like, oh, you always ask the same thing over and over and over. And the answer is, yeah, I ask the same thing over and over and over. So if you don't want to be surprised on the test, this basically has the kind of question I ask over and over and over until you feel comfortable. And again, there are more questions here than you need. So just do it up to your comfortable and then move forward. You don't have to churn it in. They're just there to help you study. Okay. Now remember, 90% of your exam is your 90% of your score is your exam. 10% is homework. So there are a lot of you who are thinking, I'm putting a lot of effort into my homework, and my homework is only complete. It is very complete. And I'll go, great, you got 10%. That's still an F. You have to be able to do this on demand. If I show you a random question without any context, can you do it? If you can do 70% of those questions, you're good. And if you can't, I'm going to flunk you. Now, I've been promising to send you out grades. I missed my chance over the weekend. So probably today what I'm going to do is, since everyone has turned in their quiz 1 and quiz 2, I will make a little thing that has a curve, if I need a curve, and it'll tell you what your grade is. What your grade is right now is what your highest quiz score is plus homework. Okay, that's what your grade is right now. Because I dropped one of your quiz scores. I do not drop a midterm. Okay. So let's get back to this. Let's do another problem. Okay. Let me pop up the problem that I want over here.
Professor, so that will be 3 quiz total and you drop 1?
Yeah. So we have quiz, midterm, quiz, final. So we're going to have the midterm you can't drop. And the midterm is worth just as much as the final. Okay. So every Monday we're going to have, we had quiz 1, quiz 2, midterm, quiz 3, and then final is on the same work week as quiz 3. That way, just about everything on the final you've already seen. Okay. Okay, now, I can almost guarantee you that this will be on your midterm. I love this problem. Okay. It has all the difficulty of all the different pieces. If you can do this, you can do any of the problems. So usually I try to put a problem like this. We'll put a little star next to it. Oops, I'm sorry, x over x plus 2. And then plus okay. So I was thoughtful and I factored that for you already. Okay. So go ahead and find the common denominator. This is missing an x plus 3, and this is missing an x plus 2. So go ahead and add them. So this one is missing an x plus 3. Now, we have a common denominator, so now I can cross all of this out. Okay, now, the trick on this one is that I have a square over here. So whenever you try to solve something that has a square or a cube in it, you have to make one side equal to 0, and then you have to factor it. Okay. So make one side equal to 0, and then go ahead and factor it. Okay. Subtract 5x. Subtract 10. And you should have x squared minus 2x minus 8 is equal to 0. And then when I factor this, I'm getting x minus 4. Okay, now, you could have no answers, you could have one answer, you can have two answers. So check if these numbers make the denominator 0. So when I plug this into here, 4 plus 2, hey, we're good. 4 plus 3, we're good. Minus 2 plus 2, oh, that makes the denominator 0. We have to cross it out. So you only have one answer. So you could have no answers, one answer, or two answers. Okay, and we're pretty much done with this section. Okay. There's one small trick I want to show you, but other than that, I think we're done. Okay. Now, I know that in terms of today was a miserable lecture. Probably a lot of people didn't get to work on their homework because they were working on the quiz yesterday night and they were planning to work on it today. So all the factoring I did made no sense. So the questions that you have after class, bring them after class. I'm expecting people to be lost on stuff. Take the pictures of the problem that you don't know, text it to me after class, and then we can just do them together and save you guys some time. Okay. So I think right now a lot of people couldn't factor, so you were so lost you didn't know how to ask the question. So I'm expecting questions tomorrow, and I will be nice when you give me questions tomorrow. Okay. Now, um, now what I want to do is just show you how to deal with whole numbers, because sometimes these things have whole numbers in them. And all you have to do when you have a whole number is put a 1 underneath it. Okay, so you can cross that out. And when I plug in 4 into the x minus 3, it works. So we don't have to worry about it. let me change the color of this. Okay, so when you have a fraction, just put a 1 underneath it, and it should be fine. Oh, I rushed in. I thought I didn't have time, but it looks like I have 5 minutes. Okay, I'll give you guys 5 minutes of your life back. Wasn't thinking I was going to finish it. So, if you have questions, just bring them tomorrow. We'll knock them out. And then I will try and email you guys out something this afternoon on what your current grade status is. Okay? And anyone else have questions?
Professor, thank you.
Thank you. Thanks, everyone. Hey, Donald? Donald, are you there?
Professor?
Yeah? Uh-huh.
So I have a question from the quiz.
Sure. Uh-huh.
Please solve it together.
Uh-huh.
The problem is 5y squared.
Okay. 5y squared,
Minus 35y
uh-huh,
plus 60.
plus 60. Okay. And we're gonna factor that?
Plus.
Oh, plus, okay. And we're gonna factor this?
Yeah, you have to factor it.
Okay. So let's
It says factor completely.
Okay. So let's pull out the GCF. Like that. So then my answer is gonna have a 5 in it. And then when I do the x factoring, I'm gonna do -3 minus 4. So you should have y minus 3, y minus 4 like that.
Okay, thank you so much.
No problem.
Professor,
Uh-huh, go ahead.
I had sent you an email in regards to the quiz. I don't know if you received
let me take a look at it. When did you send it?
Yes, was it yesterday? It was right after I took the quiz. So yeah, yes.
Okay. Let me see right now. You sent here, right? Oh,
Yes.
okay. Oh, okay. Yeah, I saw that. I just haven't had a chance to fix it yet. Yeah, I'll fix it.
Oh my God, thank you so much. I appreciate
It's no big deal. I saw it. I had other things, and yeah, I'll fix it. Don't worry about it.
Okay, thank
Okay.
you.
Thank
Have a
you.
good day.
Hi, Professor.
Go ahead.
I also sent you an email yesterday, like evening, but I didn't know if you had time to look at it.
I did. Wait, let me see. Who is this? Just because I'm not looking at my invite. Let me see. Who's talking right now? Just what's your name? Vanessa. Okay. So I have my email up. Let me stare at it. Okay. So
I mean, I completed it now. It's just the email is more vague because I was just gone for like a week and I still did class and I just fell behind.
Yeah.
My son and like everything was just so crazy last week. So I finished the quiz, but I'm really not happy with that score. But I still did it. But I tried to email you before doing it in case.
Okay. So in case that happens again, just talk to me, or you have my cell phone, right? You can just call me.
Oh, that one, yeah. Well, the number we have, you said there's issues if you message it, so that's why I just sent an email.
Yeah. So go ahead and just text me on my cell phone.
Okay.
I'll email to you right now. So if something happens like that, so the easier thing to do is to tell me before you get to that, right? So if you tell once you take the test, that's the score I'm going to take. But remember, I dropped your lowest score, right? But if you had told me, hey, this last week there's this thing going on with my kid, could you help me out? I'd say, yeah, I could help you out, and I would have extended it, and then if you just tell me after class.
Okay, because I know I said
just like
yesterday, and then I took the quiz this morning at like 5.
Yeah. So once you take it, I just got to take that score. But remember, if you do fine on quiz 3, we're okay. If you get 75% on the final, I'm just going to pass you.
Okay, I mean, because this is just like a refresher for me. You know, I'm older,
Yeah.
so that's okay. Well, thank
Okay.
you.
So this is not damning. And then next time, all you got to do is catch me right before class when it's due, which is why I make it due on Tuesday. So if something happens, and usually with parents, like you can't predict when your kid gets sick. So if a parent tells me I got sick or I got called in, then you just tell me on Monday and I can work with you.
Yeah, it's just been hectic. He has summer school, so okay. I just wanted to make sure.
Yeah, so just know that I'll give you that option, but but just know that it won't damn your grade. That'll just be the one we drop.
Okay.
Okay.
All right. Thank you.
Thank you.
Professor,
Uh-huh.
the last example that you put on board, did you double check the answer, but
Yeah.
didn't put,
So
okay.
if you put the 4 in here, 4 minus 3 is 1. It's not 0, so it's okay.
Thank you.
Yeah. Anyone else have questions? Okay. Well, hang in there, everyone.